Hi, today we're going to do the day 2 of lesson 8.3. So you should already be familiar with SOHCAHTOA, sine, cosine, and tangent. So if you need a review of what SOHCAHTOA is, please go back and watch 8.3 day 1. Okay, so to jump right in, we're going to now find angles instead of side lengths using trigonometry. Now for reference, I'm going to list SOHCAHTOA out. Some old horse caught another horse, taking notes away. That's the way I memorized it. You can come up with your own way or just remember SOHCAHTOA. Now, today what we're going to do is we're going to find angles. So it tells me right here, I'm going to find the measure of angle T. The little m means the measurement. And I'm going to round it to the nearest degree. And I know this because the directions tell me. Okay, now from this angle, what two side lengths do we have? I have the hypotenuse and I have the adjacent side. So let's fill in the blanks. 55 is the hypotenuse, and the 33 is the adjacent leg. So you say, I have adjacent, I have hypotenuse. Let's look over at my reference sheet and decide what's adjacent over hypotenuse. And so hopefully you're seeing it is cosine. So I'm going to find the cosine of angle T. Now, adjacent over hypotenuse is 33 over 55. Now, there's a new step. The new step is we have to find the angle instead of the side, so I have to use the calculator in a new way. So I'm going to do something called the inverse function, and it's right here in step number 4. I'm going to take the inverse function, which means I'm going to find the angle. So it's really important, write this down. You use the inverse function when finding angles. It is worth writing this down. Okay. So inverse is when finding angles. When you say inverse, that means there's a little -1 there. And so you don't type in the -1 to your calculator. The way you get to it is there's usually a second button or shift button on your calculator. On the yellow ones, you push the green second button, and then it takes it and it automatically says sine to the -1 or cosine or tangent to the -1. Okay, so let's practice typing this into your yellow calculator. Push the green second button, and then you're going to push cosine. So it should look exactly like this, cosine -1. Then a little parenthesis pops up, and then you should see a 33. And then when you hit divide, it shows a little division symbol, 55, and then you're going to push enter. So this is exactly what you're going to do here. And I don't like that box. And let's see what it equals. Okay, it equals 53.13. Now, it says to round to the nearest degree. So the 1 is what you're looking at. Does it round up to 54? Does it round down to 53? So hopefully you're saying it rounds down. So it's 53 degrees total. Okay, so we're going to keep doing the same thing. On example number 2, it has angle M, and you need to decide what two sides are given. Well, here's my opposite side, and I have my hypotenuse. So let's look at the reference sheet. What's opposite over hypotenuse? That is that is sine. Okay, so I'm going to use the sine. I'm going to say what angle I'm working from, and it's opposite over hypotenuse, so it's 2/5. Now, I'm doing inverse function because I'm finding the angle. So I'm going to put the little -1 there to remind me. So let's push second sine, 2 divided by 5, enter. So the way you do it is you need to say, hey, angle M, so actually write angle M, is equal to, and if you're able to round it off without writing all of it down, then do that. I'm rounding the 5. So the 5 tells the 3 to round up. So this is 24 degrees. And you're done. It's that easy. On the next one, what two sides are presented? You have the opposite side and you have the adjacent side. So this is, if you look up here, it is your tangent. Okay, so tangent of my angle. Now, it doesn't tell you the name of the angle, so I'm just going to use an X, is opposite over adjacent. So that would be 17 over 11. Now I'm doing inverse function because I'm finding the angle. So I want to push second tangent, 17 divided by 11. So angle X is 57.09. Okay, so the 0 is telling the 7 to round down. So this is 57 degrees. Little degree symbol in there. All right, so I feel like I'm flying through this. This is not a hard process. But as soon as I say that, we have like a problem with two parts. Now, I can't really cover up one side, so I'm just going to put a couple scribbles through it. I will erase it, so don't scribble on your paper. I just want to focus on the first triangle on the left. Don't worry about the other one yet. Now, we're going to go back to day one. We're going to find a side length. Okay, so how do you find side length? Well, it's similar to what we were doing in the notes today. You say, what two sides do I have? Well, my right angle is, and I just drew it in, so I know where my hypotenuse is. And so this W is my opposite. So I need opposite over hypotenuse. So let's look back at our reference sheet. Opposite over hypotenuse is sine. So let's use sine. Now, I have to know what angle you're working from. So it's sine of 32 degrees is opposite over hypotenuse. So it's W over 5. So I would recommend always putting the sine 32 over 1 and then cross multiply. Okay, so 1 times W is W. And then when you multiply the 5 times the sine, the 5 goes in front. So it's 5 times sine 32. So when you type this into your calculator, and I'm assuming you're using the school yellow calculator, you're going to type this in exactly as shown. You're going to type in 5, hit the sine button, 32, enter. So I will do that now and see what I get. I get W is 2.649, and it keeps going. Now, typically for side length, you round to 1 decimal. So that means I'm looking at these. What is happening? The 4 tells the 6 to stay the same. So this is really 2.6. Okay, so I'm going to erase those scribbles that I wrote. And I know W now is 2.6. And we need this before we can move on and find the other angle. So if I'm finding angle X, what two sides are presented? Well, opposite here, this is my hypotenuse. And so across, this is my opposite side. So I have opposite over hypotenuse again. So that is sine, and it's of angle X. And opposite over hypotenuse is 2.6 over 6. Now, here's the problem. We're finding the angle, so this is inverse function. So you have to push that extra button on your calculator. So let's push the green button, the second button, then the sine, 2.6, the division button, then a 6, and then enter. So angle X is 25.679. Okay, so we need to round this off to the nearest degree. Angles are to the nearest degree typically. Sides are to the nearest tenth typically. So this 6 is telling the 5 to round up. So we're going to say this is 26 degrees. And we're done. It's that easy. Okay, we have one more to do. And we're going to solve the triangle. So that means you find all the missing sides, you find all the missing angles. And so the first thing I notice is that you're finding two angles. So I'm just going to randomly put an X in here. Let's find this one. Could I have said, let's find N first? And I could have. It really makes no difference. I'd have to start somewhere. So let's start here. if I'm finding angle M, what two side lengths are given to you? Well, the 14 is your hypotenuse, and the 4 is your adjacent. So what's adjacent over hypotenuse? If you don't know, let's go back and look. Adjacent over hypotenuse is cosine. So let's use cosine. Cosine, and it is an M, so I'm going to use angle M, is adjacent over hypotenuse, so that's 4 over 14. Now I'm finding the angle, so that means I have to use inverse function. So I'm going to push second cosine, 4 divide by 14, enter. So angle M is 73.398. Okay, so let's round this off. 3 here tells this 3 that you're going to round down, so this is 73 degrees. Okay, now, if you're pretty confident that you did this correctly, you really don't have to use trig to find the other angle. If you think I'm pretty sure I did that correctly, to find angle N, all you have to do is take 180, which all triangles equal, subtract the 90-degree angle, and subtract the angle you just found. So, is there any way to check this, though? That's my question. Can you check this? Well, the way you could check it is you could do trigonometry, and that's what we just did here, to find angle M. We could do that to find angle N. Now, for time's sake, I'm not going to make you sit through that, but if you wanted to, you could sit and you could do it, and you could verify all three angles add up to 180. And that is a good way to double check your work. Now that you know these angles, we have one that's 17 and one that's 73. You are able to find X using day one things. You know how to find a side of a triangle. But some people think it's easier to pull an old trick out. Now, I'm going to erase so much of this stuff. Don't we know a way that we were taught probably in middle school and already this chapter to find a side of a right triangle when you know two sides? And we do. I mean, we could do trig, but couldn't we do Pythagorean? Definitely, we could do Pythagorean. So I'm just offering this as a suggestion since some people really like it. The 14 is your hypotenuse, and the other two legs are X, and I just labeled it X. You could label any letter that you like, and 4. So I square all the sides. So let's grab a calculator. 14 squared is 196. And 4 squared is 16. If I subtract the 16, I get 180. Now, I need to get rid of the square root, so I square root both sides. So the square root of 180 is 6 square root of 5. Now, if you hit the button above enter, so there's the white enter button, and then there's a white button above that with 2 little arrows, that will give that to you as a decimal. So if you want it as a decimal, you could round it off to 13.4. If you wanted to leave it in square root form, you have it both ways. So ON is 6 square root of 5, which is also 13.4. So they both work. So I believe we're done with day 2. So if you guys are free to send me a message or come in for extra help. Hope this helps you. Thank you.